In this lesson, we will see how to calculate whether I or V depends on a simple circuit where you have the resistance in series or parallel. So we will see two examples first. When we have first we have resistors in series, and for the second example, the resistors in parallel. Okay, so for the first case, so we can use basic Kirchhoff voltage law here. Okay, or you can just add up the resistance. Like since the resistance all in series, we can just add them up, where you have R total equals to R1 plus R2 plus and R3. So this will give you the value of 9 kilo ohm. Okay, so the current through the circuit is actually the ratio of total voltage, which is 9 volt. I mean, using the Ohm's law, V equals to IR, we actually can find the I value now equals to V over R. Okay, so 9 volt equals to I1 times 9K. Therefore, I1 equals to 9 divided by 9K, which will give us 1 milliampere. So I1 equals to 1 milliampere. That is the one way to do, or you can actually just apply a Kirchhoff voltage law by using loop. So can. Okay, so this is the first example. Then the next example, we will look at for a circuit where the resistors are placed in parallel. Okay, so let's see for this case, if we want to find the I here, the total current that originated from the power supply. So first we actually can get the total resistance for this effective resistance produced by the three resistors. So R total equals to R1 to R2. So this is also can be written in this way, where 1 over total equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so then using calculator you can find the value there. So R total at like 923.1 ohm. Okay, so then we can calculate the we can actually, if you want to redraw the circuit, we can redraw it such a way that you have one power supply and one resistor to understand better. So this is actually the R3, this is 9 volt, and we want to find the I1 now. Okay, so similar to before this, we can apply the Ohm's law here. So I1 equals to V over R total. we have current of 9 milliampere here. Okay, so that's actually how to do the, how to solve the circuit when you have a resistors in parallel and then resistors in series. Okay, the next example is to look at calculating the current or voltage using current divider rule and then voltage divider rule. So this circuit is actually combination of you have a series and parallel resistance, and for this circuit, assuming that you don't know to use the mesh analysis or nodal analysis, without that we try to solve the circuit and we try to get the current, respective current I1, I2, I3, and also the VR2. Okay, here. So if we, without using what we call that mesh analysis or nodal analysis, we have to simplify the circuit first. Where we can actually get the parallel resistance over here. Okay, so this would be, let's say, 1 over RT equals to we get the RT first. So we get 1.2 kilo ohm. Okay. Then we can simplify the circuit based on what the value we have now. 9 volt, 2 kilo ohm, and we have T equals to 1.2 kilo ohm here. Okay, then the total current I1 that originating from this power supply can be obtained by the basic Ohm's law, where we have a V equals to IR. The total resistance here is actually 3.2. Okay, so I1 equals to 9 divided by, we just divide by the total resistance 1.2 and 2 kilo ohm, same like for the circuit before this. Okay, similar concept. So if here we have 3.2 kilo, so we have 2.125 milliampere, like one. And then we either can find the VR2 or I2. Okay, VR2, if you want to find the VR2, because this resistance actually parallel, so the voltage will be same for parallel circuit. We can find I times RT also we can find the set voltage, or we can use the VDR, okay, voltage divider rule, to get the voltage across this resistance. Okay, so there are many methods. So this is actually VR2 not going to change. So VR2 equals to 1 times 3K sorry, not 3k, it's actually supposed to be 1.2k. If you want to use the 3k, we have to find the I2 first. Later we can compare the answer. 1.2k. So here we have 3.37 volt. Okay, so now we apply the current divider rule to get the I2. So I2 equals to, using current divider, total current multiply with, if you want to find the current across this resistor flowing through this resistor, we have to multiply with the other parallel resistance, which is 2 kilo, divide by the total resistance of this one, R2 plus R3, which is 3k plus k. Okay, so here we can get 1.125 milliampere. That's what we get now. I2. We also can cross check the answer with this current multiplied with R2. VR2 equals to I2 times 3k. So we get the same voltage, 3.37 volt. Okay, VR2 also can be applied, can be obtained using voltage divider rule. Just give an example here. Using this circuit, we already have this total resistance here. This is actually VR2. So using VDR, voltage divider rule, VR2 equals to 9 times the resistance across the voltage that we want to obtain, divided by the total resistance 2 plus 1.2. So all in case, so we can eliminate. So I didn't write it. So we get the same voltage here. So hope you understand this. I mean, using this basic principle to analyze the circuits. That's all. Thank you.